particular question is a little bit of an extension question, so you can think critically about piecewise functions. So a lot of times the piecewise function is presented as it was in the previous one, where it was less than or equal to, greater than, and you pick the first function to the left, the second function to the right. However, here our function is defined differently. It's defined as x not equal to -1, you will have this x plus 1, but if x equals -1, you have x plus 2. So let's draw a picture of what that looks like. You have -1 as your split point. To the left, when x is not equal to -1, your function is defined as x plus 1. Also, to the right, when x is not equal to -1, your function is defined as x plus 1. The only time that the function is defined using the second piece is when x is equal to -1, and that happens at x plus 2, or that function would be x plus 2. All right, so if we think critically about this, if you look at the limit of x going to -1 from the left, you are to cover this right-hand side, and you are to cover everything to the right and also the -1. So you don't actually see the -1, you're just looking near -1. And when you do that cover work, you'll see that x plus 1 is the only function that is relevant. The x plus 2 is not relevant because that is at that particular point. And remember, with limits, we're interested in near. So near -1, we're defined as x plus 1. That's the function that we'll plug into. So you'll have -1 plus 1, and that will give you 0 as your limit. The same will go when you look at the limit from the right-hand side. Again, you're supposed to cover the left, so you cover everything to the left of -1, and you cover right at -1. And when you do that, all you see is the x plus 1 function. So you'll plug into x plus 1, again, the -1 plus 1, and that gives you 0. So now, because these two one-sided limits are the same, you'll get that these two one-sided limits are the same, you'll get that the two-sided limit is also 0. So what's interesting about this question is you're not actually using x plus 2 because x plus 2 describes at -1, and you're interested in near -1 when you're finding the limit.